Good morning. This video is for pre-algebra, chapter 5, lesson 3, adding and subtracting fractions. And I know most of you are going to go, Miss DH, we know that already. And I'm going to go, yes, you should. You should know that already. But you know what? I'm also going to show you another way how to do it using basically common factors to figure it out. So there's going to be a little bit of exponents and just showing you another way to add and subtract fractions, especially if they don't already have a common denominator. All right, but if they do have a common denominator, let's say both the denominators, and again, the denominator is the bottom number, the numerator is the top number. If they both have the same number on the bottom, you just have to add the top numbers and then simplify. So 3 plus 1 is 4, 4 over 7, that is it. All right, and we're also going to be talking about letters today too. All right, so if we have 2 over k plus 3 over k, the k's are the same, so I just add the numerators, and that's going to give me 5 over k. All right, so when the denominators are different, multiply the fractions so that they have a common denominator. So if I have a over b plus c over d, if I multiply a over b by d over d, and I multiply c over d by b over b, I'm going to get ab over bd plus cb over bd. Do you guys agree that the bd's are the same on both bottom of the fractions? They are. That means that bd is a common denominator. All right? Common denominator. All right, so let's go ahead and do this one. What do I need to multiply 8 by and 6 by so that I can get a common denominator? Well, I can multiply them by each other. So if I have 6 times 1, that's 6. 6 times 8 is 48, minus 5 times 8, which is 40, and 6 times 8 is, again, 48. Subtract. I'm going to get negative 34. And then if I separate them out, I can cancel out the 2's, which gives me negative 17 over 24. All right, this should be review. I taught you guys how to simplify fractions using common factors already. So this should be review. All right. All right, so what about this one? Same type of problem. The only thing is that there's an x now. And the x really doesn't change too much. It just means that when you get down to it, you can't subtract terms that are not alike. So I'm still going to multiply by 6 and multiply by 8. And I'm going to get 6 over 48 minus 5 times 8 times x. You guys see that? 5 times 8. Well, let me use a different symbol for multiplication. 5 times x times 8, which is going to give me 6 over 48 minus 40x over 48, and the denominators are the same, but the numerators are not like terms. 6 is a constant, 40x is a term that has a variable. So you know what? I can't subtract them, so the numerator stays 6 minus 40x. All right? Cool. All right, so let's do another problem. Say I have common denominator would be 8, so all I have to do is multiply the 3/4 by 2, which is going to give me 6/8. All right, that's basically that, or that, right? And then subtract, or add. A negative 7 plus 6 is negative 1, which gives me negative 1/8. Now, if I have a denominator at the bottom, I need to multiply still. So if I'm going to get 7 to look like something that has an m in it, I have to multiply 7 by m. And if I need m to have something with a 7 in it, I need to multiply m by 7. Therefore, the common denominator is 7m. But what do I do to the bottom? I have to do to the top. If I multiply 7 by m, I have to multiply 3 by m, and the same with 2. If I multiply the m by 7, I have to multiply 2 by 7. So I'm going to end up with 3m over 7m minus 14 over 7m. Since 3m and 14 are not like terms, again 14, since 14 is a constant and 3m is not, you cannot subtract them. It is just 3m minus 14 over 7m. That's it. Can't go any further than that. Can't simplify the numerator any further. Therefore, that is your final fraction answer. All right. Now, let's do the same thing we were doing before, but with a slightly different method. This is called using factoring to find common denominators. And basically what it is I'm going to take each denominator that isn't common, and I'm going to break it up into its factors. So 8 breaks down into 2 times 2 times 2, which is 2 to the third power. and 12 breaks down into 2 times 2 times 3. So basically how this is I need to get it so that both fractions have the same denominator thing going on. So you see how I've got the 3 over 2 to the third? I need to get a 2 to the third under and by the 5 over 2 to the second times 3. So that's what I'm going to do. I'm going to add a second 2 because as you can see here, 2 to the third plus 2 is really 2 to the third. So by multiplying here by 2 and 2, multiplying the 5 times 2 and the 2 to the second times 3 to the second by 2, I'm really just making up for that there. Alright? Now, if I do it with the other side, I still need to get the 2 to the third to have a 3 in it, because there's a 3 right here. So to do that, I'm going to multiply by 3. Alright? So now basically I have the same denominators, and just whatever I changed on the bottom, I also changed on the top. So now I'm ready to simplify my fractions. I've got 9 over 24 because 2 to the third is 8. 8 times 3 is 24. And then I also have 10, which is 5 times 2. Right? 5 times 2 over 24 because again, 2 to the second is 4. 4 times 3 is 12. 12 times 2 is 24. So again, I'm still getting a common denominator of 24. It's just like we were doing before. This is just another way to think about it. And honestly, thinking about this like this now is going to help you in Algebra 1. So even though you might think it's a pain in the butt to learn a new method for common denominators, I still need you to learn this because knowing it now will make your life easier a little later. Alright? Okay, now that I have a common denominator, I can add and get 19 over 24. Alright, next problem is 7 over 12 minus 5 ninths. Do the factor tree. 12 breaks into 2 squared times 3, whereas 9 is 3 squared. So I need to get another 3 on the 7 over 12 side, right? I need to get another 3 over there. And on the 5 over 9 side, I need to get 2 2's because there isn't any 2's over there. And if I'm going to come up with a common denominator, I need the same factors on both denominators. So there's my 2 2's, or 2 to the second. And again, what I do on the bottom, I have to do on the top. And then I need my 3's. Now I already had 1 3, so I only need a second 3 to get 3 squared, right? Since I had 1, I only need 1 extra. Alrighty? So then 7 times 3 is 21. 2 to the second times 3 times 3 times 3 is 36. Minus 2 times 2 to the fourth, or 2 to the second, that would be 4. 5 times 4 is 20. And then again 36 at the bottom because 3 times 3 is 9, 2 times 2 is 4, 3 times 9 is 4, 36. 9 times 4 is 36. Sorry guys, I'm really tired. Moving on. Okay, so then you subtract and you get 1 over 36. 1 over 36. Sorry, I was a little fast. Okay. Alright, so just a reminder, you're going to have to write mixed numbers as improper fractions before you go ahead and find the LCD, which is the lowest common denominator. So just remember, it's the denominator times the whole number plus the numerator. So there you go. So 4 times 5 plus 3 is 23, which is 23 over 4. We still have 7/8. We're going to break the 4 down and the 8 down. Now again, I know you all know that the common denominator is 8. I'm going to show you again how to use the factoring method to find the common denominator. So we have 23 over 4 squared plus 7 over 3 squared. Well, the only difference is this has 3 2's and that has 2 2's, so I only need to add 1 more 2 to the 23 over 2 squared part. There are my 2's. Again, what I do on the bottom, I got to do the top. 23 times 2 is 46. 2 to the second power times 2 is 8. I still had 8 on the bottom for the 7 2/3. Sorry. And, I'm sorry guys. And then 46 plus 7 is 53. Simplify the fraction, and you're going to get 6 5/8. Beautiful. All right, I'm hoping you get this, so I'm only going to just quickly run through the next problem, and you can take a look at it if you need to. Ask me questions about it, because I know this is obviously going a little fast, but you can see what I had to add on both sides to get them to be the same. Since I needed 2 3s over here, I needed an add a 3 here. Because I had a 2 here, or excuse me, because I had a 2 here, I had to add 2 2s there. So again, because I had a 2 there, I had to add those there. All right, gives you that. Okay, I'm done. Bye, guys. Peace out.